Now, necessary conditions to execute SHM. Total mechanical energy of the particle should be conserved. That is, kinetic energy plus potential energy must be constant. This is called the law of conservation of energy. That is, a pendulum bob or any particle executing SHM is obeying law of conservation of energy. That is, two energies are added up and that they remain constant. In a linear SHM, the restoring force or acceleration acting on the particle should always be proportional to the displacement of the particle and directed towards the mean position. Now this is depicted mathematically. That is, larger the displacement, larger will be the restoring force. That is, F is proportional to Y. Similarly, whatever law is applicable to force, the same law is applicable to acceleration. So A is proportional to Y, or F is equal to minus Ky and A is equal to minus Py. K is spring constant or the force constant and P is supposed to be the acceleration constant. F is the restoring force, A is acceleration, and negative sign shows the direction of force and acceleration towards mean position, that is towards the equilibrium position. And Y is the displacement of particle away from mean position. So displacements are always away and the forces are towards the mean position, and these forces are called the restoring forces generated due to elasticity and inertia of the medium. Now we come towards angular SHM. The restoring torque or acceleration acting on a particle should always be proportional to the angular displacement of the particle directed towards the mean position. So in one equation, we have written tau, that is torque, proportional to minus theta, and alpha, that is equal to minus theta. Comparison of linear and angular SHM. Now we have to make certain comparisons. So what we find in the linear SHM, F is proportional to minus Y, and angular SHM, we find torque is proportional to minus theta. Minus always indicates about the direction, whereas the physical quantities are F and Y or torque and theta. So towards the linear SHM, as I have explained earlier, we can write F is equal to minus Ky and torque can be written as minus C theta. And in the linear SHM, we find K is the restoring force, and in the angular SHM, C is the restoring torque or constant, restoring torque constant. Now there are various formulas here, like acceleration minus Q over M into Y, and another equation number 3 is d square Y over dt square plus K by M into Y, where d square Y over dt square is supposed to be the acceleration of harmonic oscillator. The fourth position is A is minus omega square Y. Negative sign is indicating again A and Y are in opposite direction and omega is angular frequency. So angular frequency can be written as K over M, or it is A over Y. Anyway, we can calculate and the formula will become omega is equal to under root K by M or 2 pi over T. Now, if we wanted to find T, it will become 1 over 2 pi under root K by M. Similarly, the another acceleration, that is alpha is equal to minus C over I into theta, where C is the couple. So we have taken the second degree equation, that is differential equation. So d square theta over dt square, that will be adding to it C into theta, and that will be 0. Omega is calculated by C over I under root, and omega is 2 pi n. So we can have the expression, that is omega is 2 pi n or 2 pi by t. We can find both the values. Now we come towards the general equations of SHM with regard to displacement. The displacement can be given in terms of y is equal to a sine omega t or y is equal to a cos omega t. Omega t is the phase angle, whereas a is supposed to be the amplitude. So all the equations of SHM are either the sine function or the cosine function, and if they are in some other pattern, we have to convert it to sine function and cosine function. Now, general displacement equation of SHM. We know that force acting on the particle is mass into acceleration by second law of motion, but otherwise in oscillatory motion it is minus ky. So A is calculated as minus ky over m. Then we take modulus because acceleration is that is called scalar quantity. So it is A is equal to minus ky over m. And the same thing is dv over dt, and dv over dt can be written as minus dv over dt. That is again the directions are opposite. And derivative of velocity with respect to time, that is called acceleration. Now what we have done, we have used the differential calculus and some integration to come to the desired results. So if you will find one of the caption we have written, that is v into dv over dt. That is, we have written that displacement y and derivative of velocity with respect to time, that is called velocity. And this is equal to v into dv by dt is equal to minus k over m y dy over dt, because v is equal to dy over dt. dy over dt means derivative of displacement with respect to time. Now we have integrated the function, integrate v with respect to v and integrating ky over m with respect to dy. So if we integrate v with respect to v itself, the number will come as v square over 2. And similarly is the integration of ky over m. We will take out k over m outside and integration 1 dy. So that number becomes a given number, and it will be v square by 2 is equal to minus ky square over 2m plus c. Now if we make calculations, y is equal to 0 and v is equal to 0, then c will be equal to v naught by 2. Now this equation we use for calculating, that is c, and now v square over 2, that will be minus omega square y square over 2 plus v naught square by 2, because omega square is equal to k by m. So we go on further calculating, that is, we have calculated the value of v. We have cancelled off 2 from both sides in the denominator, and the value of v is calculated by taking the square root. Now v means velocity, and now we have taken dy over dt. For v, we have written dy over dt, and that becomes v naught square minus omega square y square. Now we have integrated the function, and it is equal to integration 1 dt, that is t only. So we are elaborating this statement in terms of inverse function, and that result comes as 1 over omega sine inverse omega y over v naught is equal to t plus c1, because v naught is omega a. Now the equation is y is equal to sine omega t plus omega c. Take out omega as constant. One is omega t, other is omega c. At t is equal to 0 and y is equal to 0, if the velocity is m positive direction, and y is equal to a sine omega t if the velocity is in negative direction. So the displacements will be negative or positive depending upon the situation shown here. So y is equal to minus a sine omega t, but y is a displacement and displacement is vector. So if we take the modulus, the function will become y is equal to a sine omega t. Now points regarding the displacement of SHM. Now in the first equation, x is equal to a sine omega t plus phi, where phi is supposed to be the phase angle. The phase angle phi is given as 2 pi x, or it is phase angle that is given as phase angle. Phase angle means we have to find the phase. Uh, Phase means, when we use the term phase means angular variation. That is what the meaning of phase. One is path difference, the other is phase. Path difference is the linear lagging between the vibrations communicated by the source, but phase difference is the angular lagging between the vibrations communicated by the source. And simply phase means position and direction of particle at an instant of time. Phase difference means angular lagging. So, the general equation of SHM when phase is given is A sine omega t plus phi or A sine A cos omega t plus phi. So, the functions must be in terms of sine or cosine. The general equations can be estimated by watching whether particle is moving in the first quadrant and its motion is terminating in the first quadrant, or the motion of the particle starts, that is from position x, and the motion terminates in the first quadrant. Similarly, if the particle is moving from a point in the first quadrant and the motion terminates at another point in the second quadrant, then we will again get the equation of SHM. Now here in the last equation, like x is equal to a1 sine omega t plus a2 cos omega t. Now capital T stands for time period and n stands for frequency. So wherever omega we write, that is normally written as 2 pi n. So omega angular frequency is 2 pi n, but n is 1 over t, so the net function will become 2 pi n or 2 pi by t. Now we come to the definition of phase, which I have just now explained earlier. Either it is in the terms of lagging or the position. The physical quantity which represents the state of motion of a particle is called phase. Or very simply we can say that phase is the position and direction of particle at an instant of time. The quantity omega t plus phi represents the equation for displacement of an oscillator as the phase angle. The difference in phase angle of the two oscillators is called the phase difference. So phase difference is calculated by function phi 2 minus phi 1. The difference in phase angles at different times of an oscillator is also called the phase difference. Now we have written here delta f, and delta f is equal to phi 2 minus phi 1. That is phase at one position, phase at other position, and their difference is, that is, change in frequency, and that is equated, or that is taken as omega t phi 2 minus omega t phi 1, where omega t plus phi 1 and omega t plus phi 2 are phase angles of the two oscillators at time t.